Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to take a look at how you find the number of permutations when the objects are arranged in a circular formation. In previous videos I've talked about how you find the number of permutations if those objects are arranged in a line. And if you're not sure about that concept, just go back and take a look at those videos. But to summarize it, we found that if there's n objects, the number of arrangements will be n factorial. So for example, if we had 3 objects, the number of arrangements of those 3 distinct objects would be 3 factorial, and that's equal to 3 times 2 times 1, which is 6. However, if those objects are arranged in a circle rather than a line, there's fewer arrangements or permutations. The formula for that is n minus 1 factorial, and I want to look at some examples to see where this formula comes from. So let's see how many ways we can arrange 3 Skittles in lines and in a circle. Here's our 3 different colored Skittles, and I'm showing you all of the different arrangements or permutations of those if they're arranged in a line. So you can see that each arrangement is different, and there are a total of 6. 3 factorial, which is equal to 6. If we were to arrange those same 3 Skittles in a circular formation, there are actually only 2 different ways that we can arrange them. If you take a look at this first one, we've got green, yellow, orange. We also have yellow, orange, green, and orange, green, yellow, but in a circle, those 3 are the same thing. Similarly, green, orange, yellow is the same as orange, yellow, green, and yellow, green, orange, if they're in a circle. So we have 1/3 of the number of permutations as we did when they were arranged in a line. So what we found is that when we arranged those objects or Skittles in lines, we had 6 different possible arrangements. However, when we arranged them in a circle, we only had 3 minus 1 factorial ways to arrange them, which is equal to 2 factorial, which is 2 times 1, which is equal to 2. So you'll notice that this number is 1/3 of this number. Let's take a look at 4 distinct objects, in this case 4 different colored Skittles. If they're arranged in a line, we have 4 factorial ways to arrange them, and that's equal to 4 times 3 times 2 times 1, which is 24. However, if they're arranged in a circular formation, we would only have 4 factorial divided by 4. The reason that we're dividing by 4 is if you take a look at this arrangement that's currently shown, purple, orange, green, blue, that formation is actually the same as orange, green, blue, purple, and that's the same as green, blue, purple, orange, and that's also the same as blue, purple, orange, and green. It's just shown from a different perspective. So that's the reason that we always divide by 4. Now 4 factorial is 4 times 3 times 2 times 1. When we divide by 4, the 4 cancels. 3 times 2 times 1 is 3 factorial, or 6. Notice 1/4 of the value of the number of permutations if they're done linearly. Let's try some other examples. If we had 6 distinct objects, so I have 6 different colored Skittles, if I were to arrange them in a line, there would be 6 factorial number of ways to arrange them. However, if we were to arrange those same 6 objects in a circle, there would be 6 factorial divided by 6 number of ways to arrange them. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Then when we divide by 6, the 6 will cancel, and that's equivalent to 5 factorial. So notice that the factorial is 1 less than the number of objects. If we had 11 distinct objects and we were arranging them in a row, there would be 11 factorial number of arrangements. But if we are arranging them in a circle, we would have 11 minus 1 factorial ways of arranging them, which is 10 factorial. and so on. So the formula for finding the number of permutations of distinct objects arranged in a circle is n minus 1 factorial. If you're interested how we derive the formula, it's actually obtained by taking n factorial, the number of objects is n, dividing by n. So n factorial is n times n minus 1 times n minus 2, and so on, down to 1. N is in the denominator, it will cancel with n in the numerator, and what you're left with is n minus 1 factorial.